Hi guys, Daniel here. Hope you guys are doing well, and I'm sure you guys are studying hard. So today we've got paper 3 of the Edexcel June 2023 series for Foundation GCSE, and yeah, couple of tricky questions. I think this was the easier paper out of the three papers for this year, and yeah, as normal, you'll have the timestamps in the description, so you can just access whatever question you like. You don't have to watch the whole thing, and yeah, that's pretty much it from me. Let's get into it. Okay, so question one says we need to write the number 3,107 in figures, so that's not too bad. So 3,000, comma 107, so that's one mark. Question two says we need to write 3 over 10 as a percentage. Now remember, you do have a calculator, so remember to go from fractions to percentages, you just times by 100. Or what you can do is say I've got 3 over 10. And remember, if I want it as a percentage, I need this to be out of 100. So you can just times this by 100, times this by 10, sorry, and that will give you 30 on the top. So it's going to be 30%. And then question three says we need to simplify m plus m plus m plus m. That's 4m's in total. That's just going to be 4m. And question four says we need to change 4,000 grams into kilograms. Now remember, there are 1,000 grams for every kilogram. So to get 4,000 grams, we're just going to times by 4. We're going to divide by 1,000, sorry, to get 4. But yeah, so it'd be 4,000 grams here is going to be 4 kg. Or you could have just divided 4,000 grams by 1,000 to get you into kilograms. So it's going to be 4 kilograms here. And then question five says, write these numbers in order of size. Start with the smallest number. So the smallest number is going to be negative. It's going to be negative 5 first. And then it's going to be the next second number, negative 2. And now we're dealing with positive integers, so it's going to be easy now. 3, 7, and 9. And that's it. Okay, so question 6 says the diagram shows a shape on a centimeter grid. Find the area of the shape. So it's a compound shape. What I would do is I would split it into two rectangles like this. And for the one on the left, well, it has a base of 2 and a height of 1, 2, 3, 4, 5, 6. So the area is going to be 6 times 2, isn't it? Which is going to be 12. So I'm going to put that in a circle here. 6 times 2 is 12. That's fine. This one has a base of 1 and it has a height of 2. 1 times 2 is 2. So it's going to be this area, 12, plus that area, 2. 12 plus 2 is 14. So it's going to be 14 centimeters squared. Part B says we need to find the perimeter of the shape. So finding the perimeter of the shape, we need to add all the sides together. So we've got that to be 6. That's fine. 2 plus 1 is 3. So I'm going to rub this out. This one is 3. What else do I know? This is 2. The height of this one is 2. This one is a 1 right here. That one just goes 1 across. 1, 2, 3, 4. This goes 4 across. And this is 2. So all of the numbers on the outer side are the different sides of the shape. So we're just going to add all of those together. So it's going to be 6 plus 2 plus 4 plus 1 plus 2 plus 3. Now remember, this is a calculator paper, so always use your calculator just to be safe. 6 plus 2 plus 4 plus 1 plus 2 plus 3 is equal to 18. So it's just 18 centimeters. That's question 6. Let's go to question 7. Question 7 says, here is a four-sided spinner, right? It says Samina spins the spinner once. Choose the word that best describes the probability that the spinner lands on 2. Now, we're looking for a probability. If it lands on 2, well, how many possibilities are there for a 2? There are 2, right? How many total outcomes are there? There are 4. So the probability of it landing on 2, I'll just write probability of it landing on 2, lands on 2, is going to equal, there are 2 options for a 2, and it's out of 4, which is 1 half, which is 50%, 0.5, 50, 50. So the answer is going to be evens. Now, part B. It says choose the word that best describes the probability that the spinner lands on a number less than 4. Well, there are 4 options, and you can either have a 1, 2, or a 3. Each of these are less than 4. So it's absolutely certain that when you spin it, it's going to land on a number less than 4. So it's going to be certain here, which means 100% of the time it will land on a number less than 4. Now, part C says, let's just zoom in a little bit. It says Ralph rolls a bias dice once. The probability that he gets the number 5 is 0.4. Work out the probability that Ralph does not get the number 5. Well, remember, we're dealing with probability here. We know that the probability of it landing on 5 is 0.4. Well, the only other scenario is if it does not land on 5. I remember we know that all probabilities must add to 1. So the probability of it not landing on 5, right? Not landing on 5 is just going to be equal to the total probabilities, which is going to be 1, and we're going to take away the 0.4. And that's just equal to 0.6. And that's it. And that's question 7 finished. Okay, so question 8 says a quadrilateral has 4 right angles and 4 sides of equal length. Write down the mathematical name of this quadrilateral. Well, that is just going to be a square, no? Like that. It's going to be a square. The diagram shows a solid shape, and we need to write down the mathematical name of this shape. Now, this is a 3D object, and we can see that we've got two faces which are rectangles, and the other sides are squares, right? They're not the same length. So what we'd call this is just a cuboid. Yeah. If they were all the same, it would be a cube, but this is what we call a cuboid. So that's done. Now let's go to the next one. Question 9. It says the table shows the number of books read by 4 people in 1 month. Part A, well, let's look at the table. We've got the person column with their names, and we've got the number of books on the right, and it says we need to work out the median number of books. Well, the number of books are here, and we need the median number. What you'd want to do is order them in terms of smallest to largest. So I'm going to write 1, I'm going to write 5, I'm going to write 7, I'm going to write 9. Now remember, the median is the middle number. Now the middle is just going to be in between 5 and 7, which is quite clearly a 6. So the median will be 6 books. And we need to find the range. Well, very easy. The range is just the largest take away the smallest value. So the range will be 9 take away 1, which is just equal to 8. So I'll put an 8 here. And then now part C says, on the grid, draw a bar chart to show the information on the table. Now, it's 3 marks, so you've got a couple of things that you need to get. You need to obviously label your axes, your horizontal and your vertical axes, and you obviously need to draw the bars themselves. Now, let's look at the table. We've got the persons here. This is going to be our horizontal or our x-axis, and the number of books is going to be our vertical axis, isn't it? So I'm just going to put person here, and then who do we have? We've got Jimena. So what I'll do is I'll just write X for Jimena, and then I'm going to write M for Martha, and I'm going to write K for Kezia and T for Tabby. So K for Kezia, T for Tabby, and then I'm going to now label the vertical axes for the number of books. So I'm just going to write number of books here, number of books, and then we can just do it in ones, can't we? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so now Jimena has 7 books, so we need to draw a rectangle up to 7. So what I'm going to do ink to shape because it just makes the rectangle very nice. Do like that. Perfect. That will be Jimena. Martha had how many books? 9. She has the most. So I'm going to do this here. Like that. And then Kezia has 1 book, so I'm just going to draw 1 block like that. Should be fine. Let me just move it a bit to the side. Yeah, that's better. And then 1 more. Tabby had 5 books, so I'm going to do it like this. And that's it. That'll give you the 3 marks. Okay, so question 10 says Wayne begins walking at 8:30 a.m. He walks for 1 hour and 45 minutes. Wayne then rests for 15 minutes. He then walks for 85 minutes to a calf. Does Wayne get to the calf before 12 noon? You must show how you get your answer. And this is how many marks? It's a 4 marker. Okay, so firstly, we're starting at 8:30 a.m. I'm just going to write 8:30 a.m. here. Now, step 1 says that he walks for 1 hour and 45 minutes. So I'm just going to say here, walks, and I'm just going to write equals 1 hour and 45 minutes. Now, what I notice about step 2, which is just after here, is that he rests for 15 minutes. And the reason why I'm looking at that now is because 1 hour 45 plus 15 minutes is just 2 hours, right? So these two together will make 2 hours. So we know that after Wayne walks and he rests, it takes 2 hours of his time. So that means we're going to be at 10:30 a.m., aren't we? Just 2 hours more. We just write plus the 2 hours here. Perfect. Now, what else do we know? After the 2 hours, he then walks for 85 minutes to a calf. So we're at 83. He was 85 minutes. He walks again, and this takes 85 minutes. 85 minutes. Now, what I would do is I would convert this into hours and minutes, right? Well, we know that there's 60 minutes in an hour. So it's going to be 60 mins, right? Which is 1 hour plus 25 minutes. So in other words, it's just an hour and 25 minutes after 10:30 a.m. So I've got 10:30 a.m. If I do 1 hour, 1 hour, that's going to take me to 11:30. And then now we know that there's a remaining 25 minutes. I'm going to add 25, which is going to give me, it's going to take me to 11:55 a.m. So the answer to the question, does Wayne get to the calf before 12 noon? He gets there 5 minutes before. So the answer is yes. So you're just going to put a yes. Remember to always answer the question as well. And that will give you the 4 marks. And that's it. Okay, so it says Gabriel thinks of a number. He multiplies his number by 5 and then adds 7. His answer is 72. What number did Gabriel think of for 3 marks? Now, what you want to do is remember they're telling us that Gabriel thinks of a number that we don't know. So you want to use algebra. You're going to call it x. So I'm going to call it x, right? And then the first thing that happens is that this number, whatever it is multiplied by 5. He multiplies his number by 5. So what I'm going to do is I'm going to start here. So my start. And then the first part is that it's going to be multiplied by 5, as we can see. Yeah? X times by 5, this is going to be 5x. So this is this part of the sentence done. Yeah? We've done the step in yellow. After that, the number has 7 added onto it, right? It says, and then add 7. So what I'm going to do now is add on 7. And that will leave me with, well, 5x add 7 is just going to be 5x plus 7. Remember, you can't combine these because they're not like terms. So you're going to leave it as 5x plus 7. Now, it says that his end result is 72. Well, this is our end result. We are finished. So what this means is that this must equal 72. And now you've formed an equation that you can solve. So I'm going to write up here again. So we've got 5x plus 70, 5x plus 7 is equal to 72. And we need to figure out what number Gabriel thought of. Now, the number that Gabriel thought of in our case is x. So we need to find out what x is. Now, remember, you're solving an equation. You're trying to get this by itself. You've got this to get rid of, this plus 7, and you've also got this 5 to get rid of as well. Now, whenever you're solving a question in this way, when it's set up like this, you always get rid of the number that's furthest away, which is in this case a 7. We need to move it over the equal sign by taking away 7 from both sides. So I'm going to get 5x is equal to 72 take away 7, and that is just going to be 65, isn't it? So we get 5x is equal to 65. So you're just going to divide both sides by 5, aren't you? 65 divided by 5. Remember, you have a calculator, so you may as well use it just to be safe. 65 divided by 5 is equal to 13. So therefore, x is equal to 13. And that's it. So that is question 11 done. Let's go to question 12. Question 12 says, some students took a guitar exam. The pie chart shows information about the grades that the students got, right? So we've got the different degrees and so on and so forth. And it says, write down the modal grade. Well, in the case of a pie chart, the modal grade is going to be the biggest, the angle with the biggest proportion, isn't it? Right? The sector with the biggest proportion, which is going to be the biggest angle, which is going to be 150 degrees. So therefore, the modal grade is going to be a merit. So that's done. That's 1 mark. Part B says 7 students got distinction. Work out the total number of students who took the exam. Now remember, the guitar exam. So we're looking at distinctions here, and that represents 105 degrees, right? So what we can say is, well, from this, remember, because it needs to be representative, right? The 105 degrees that we can see represents distinction. This has to represent 7 students. Now remember, the total amount of students is going to be represented by 360 degrees. So we basically need to work our way to 360 degrees. Now, if 105 degrees represents 7 students, we could figure out what degree would represent 1 student, right? How do we do that? Well, how do I go from a 7 to a 1? I'm just going to divide by 7, aren't I? So I'm going to divide both sides by 7, and I'm going to do this on my calculator. So it's going to be 105 divided by 7, isn't it? 105 divided by 7. This is equal to 15 degrees. So I know that there's 15 degrees for every student. Now we know that there's going to be 360 degrees, which represents the total amount of students. So I need to work out how many students represents 360 degrees. Now I know that 15 degrees represents one. You need to ask yourself, well, how many 15s go into 360, right? And the way you do this is just by dividing. So you're just going to do 360 divided by 15, and that gives me 24. So there are 15 24s, right? Or there are 24 15s, I should say, which will make 360. So it's going to be 24 students, right? Because we're just going to times both sides by 24. Times by 24. And that's it. So the total number of students who took the guitar exam is just 24. I'll put it in a square. That. And that's it. And that'll give you 4 marks for question 12. Okay, so question 13 says Rowena drove from her home to a beach. Here is a travel graph for her journey. So we've got the distance from home in the vertical axis and we've got the time on the horizontal axis. And it says for part A, Rowena stopped at a cafe on her way to the beach. How many minutes did Rowena take to drive to the cafe? So remember, we're dealing with a distance time graph, right? The further the graph goes up shows you how far away you are from your starting point. And if there are any horizontal lines, that just means that you are not going anywhere. You are staying put. So if Rowena stopped at a cafe on her way to the beach, it must be represented by this horizontal line here. So to ask ourselves, to answer the question, how many minutes did Rowena take to drive to the cafe? Well, she drove to the cafe from this point to that point, right? And we need to figure out what that time is. Well, that is bang in the middle of 12 and 1 o'clock. That's going to be 12:30. So it must have taken her 30 minutes to drive to the cafe. So I'm just going to put a 30 there. Put a 30 there, 30 minutes. Now that's done. Part double I says write down the distance from Rowena's home to the cafe. Now remember what I told you about distance time graphs. You look up it to see how far you've traveled. So if we're here at 12:30, then the distance is just going to be this one here, which goes up to 10. So therefore it's 10 miles. So I'm going to put 10 here. Now, the next part says Rowena stayed at the beach for 1.5 hours. She then drove home without stopping. Rowena arrived home at 4 o'clock. On the grid, complete the travel graph. So what I'm going to do, I'll just screenshot this part of the question here so I don't need to keep going up and down. And I'll just put it here just so we can see it. Okay, so I've got to put this here. All right, so Rowena stayed at the beach for 1.5 hours. Remember, if you're staying put, it represents a horizontal line on a distance time graph. So I'm going to draw a horizontal line for 1.5 hours, which is an hour and 30 minutes. So we are here. Remember, we are at the beach now. Now this time is what? That time again is bang in the middle. That is going to be 1:30 p.m. And we stay there for an hour and a half. So that's going to take me to 3 o'clock, isn't it? So 3 o'clock is going to be over here. So I need to draw a horizontal line from 1:30 to 3 o'clock. So it looks something like that. And then let me just put this here. Like this. So that would be the first part. Now it says she then drove home without stopping. Rowena arrived home at 4 o'clock. On the grid, complete the travel graph. So now we're at 3 o'clock and she drives home without stopping. So let me just make this a little bit more straight. Now, what we need to do is remember, if we're going back home, we're going down on a distance time graph. We're going back to our starting point. So what we need to do is draw a line going down. And because it's not stopping, it's going to be a constant gradient. And it's going to go to 4 o'clock. So I'll just do it like this here. So it must look something like this. And that will give us the marks for part B. Now, part C says we need to work out the average speed for the journey from the beach to Rowena's home in miles per hour. Well, that is going to be represented by the line going down, this part of her journey, this right here. So if I want to work out the average speed, well, let's see how fast she's traveled. Remember, speed is distance divided by time. Well, what we can see here, to be fair, is that, well, she's 35 miles away from home, right? And she gets home at 4 o'clock. So she starts at 3 o'clock, gets home an hour later. So what we can say is that in the 1 hour she travels, right? She's traveled 35 miles. Yeah? 1 hour from 3 to 4, she travels 35 miles, isn't it? Because she's 35 miles away from the beach. So to get back home, she travels 35 miles. So the average speed in miles per hour, well, it's just going to be 35 miles per hour, isn't it? It's going to be 35 mph. So the answer is just going to be 35 miles per hour. And that's it. And that's question 13 finished. Okay, so question 14 says 120 boxes cost £6, 270 bags cost £10. A bag is cheaper than a box. How much cheaper? Give answer in pence, correct to 1 DP. So I'm just going to underline that in pence. So we've got boxes, we've got bags. Apparently, bags are cheaper. What we want to do to work this out is essentially work out the cost of one box and one bag and then compare essentially. So I'm going to write 120 boxes is equal to £6. And I'm going to write 270 bags is equal to £10 here. Now I'm going to work out the cost of a single box and a single bag to compare them. So I'm going to put one box here, and this is going to equal, I'm going from 120 to 1. That means I need to divide both sides by 120, don't I, to get the cost of one box. So I'm going to get my calculator here. I'm going to do 6 divided by 120. And that gives me 1 over 20, which is 0.05. So that's going to be 0.05 here, right? And now, this is in pounds, by the way. I'm going to convert to pence in a bit. And then now we need to work out the cost of one bag. And to do this, we need to go from 270 to 1, which means we need to divide both sides by 270, don't we? So I'm going to do 10 divided by 270. 10 divided by 270, that gives me 1 over 27, which is 0.037, blah, 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 isn't it? Yeah? Blah, blah, blah. So we can see that bags are definitely cheaper. By how much? Well, what we can do now is convert these into pence now. So what I'm going to do is I'm just going to convert this into pence now by times them by 100, aren't we? Yeah. So doing that, that's just going to be 5 pence, but I'll just do it here. 0.05 times 100 is going to give us 5, so it's going to give us 5 pence here. And then this one, I'm going to times by 100, go back here. Where is it? Get that answer. And I'm gonna do this number times 100 to get into pence, which is going to be 3.703 blah blah blah. So I've got 3.703 blah blah blah, and this is in pence. So how much cheaper is it? We're just gonna take the difference. We're gonna do 5 take away 3.703 blah blah blah, and then so I've got that number stored already, so I don't need to write out again. I'm gonna write 5 take away answer, and we get 35 over 27, which is 1.29 blah blah blah. So I'm going to just write this here, 1.296 blah blah blah. They asked us to give it to one decimal place. What is that to one decimal place? That's just going to be 1.3. So the answer is just going to be 1.3 pence. And that's it for question 14. Let's go to question 15 and see what we've got. It says there are only red beads and green beads in a bag. The number of red beads to the number of green beads is in a ratio of 1 to 4. There are 35 red beads in the bag. Work out the total number of beads in the bag. Okay, so we've got red and we've got green, right? And this is in the ratio 1 to 4. Now remember, when you're dealing with ratios, you're thinking of a total amount and it's split into parts, right? The ratios are the parts. So we know that there are 35 red beads, and we also know that red represents one part. So what I can actually say is that, well, the 35, right, red beads is going to equal one part for sure. Now we're trying to work out the total number of beads in the bag. Well, how many parts are there in total? We're just going to add the two parts together. 1 plus 4 is equal to 5. So there are 5 parts in total. And I know that one part represents 35. So if I want to work out what 5 parts represents, which is going to be the total, I'm just going to do 1 times 5, which means I need to just do 35 times by 5. So that's all I'm going to do. I'm just get my calculator here. I'm going to do 35 times by 5. And that gives me 175. So therefore, there are a total of 175 beads in the bag. And that's it. And that will give you the 2 marks. And that's question 15 finished. Okay, so question 16 says, describe fully the single transformation that maps shape A onto shape B. And this is 2 marks. So with this one, I'm obviously using a computer, so I don't have a protractor and tracing paper with me. But what you could do is if you have a gauge of it, if you look at it and you do this a couple of times, you would be able to spot the type of transformation. And firstly, you don't need tracer paper or protractor to spot the type of transformation. We're looking at shape A, and we can see that the proportion of it is changed in terms of it's been rotated, isn't it? Right? Now we can see that this top part, right, on A has now gone here, and then this one has gone here, and then that one has gone there. So this has definitely been rotated, and it's 90 degrees, isn't it? I'll just show you something as well, just to really bring it home. I'm gonna just paste a picture. So this is a triangle which mimics A, and if I get my thing here, and if I click on this and I rotate it to the left like that, can you see it goes up to B now? So it's definitely been rotated 90 degrees, and it went to the left, so that's going to be anti-clockwise. So you're just going to say rotation, 90 degrees, anti-clockwise, anti-clockwise, like that. And as well as that, what you need to do to get the extra mark is to figure out what the center of rotation is. And that's where the tracer paper comes in. So what you would do is you'd obviously get tracer paper, you'd trace this shape here, and then obviously you'd rotate it 90 degrees, but then you're just going to guess as to where the center of rotation is. And with this one, it's just going to be at the center. You can try it on your own. But yeah, so the answer is rotation 90 degrees, and the center is just going to be 0, 0. Or the origin, and it'll give you the 2 marks. And that's done. Now let's go to question 17. It says the diagram shows the position of town T. Okay. It says the town R is 55 kilometers from town T on a bearing of 65 degrees. Mark the position of town R with a cross X. Use a scale of 1 centimeter to 10 kilometers. Okay, so there's a couple of things going on. There's only 2 marks, sorry. Now again, you need a ruler and a protractor for this one, but I'll just show you how it would work. So firstly, we've got the scale which says 1 centimeter is equal to 10 kilometers, right? And we know that the town R is 55 kilometers away. So what we need to do is figure out how far 55 kilometers is based on the scale here. And all you're going to do here, how many 10s go into 55? You're just going to do 55 divided by 10, isn't it? Which is just 5.5. So I'll just show you here. 55 divided by 10 is equal to 5.5. 11 over 2, 5.5. So we're going to times by 5.5 to get me to 55 kilometers, which means I'll times that by 5.5 as well. 1 times 5.5 is just 5.5. So we know how far we need to travel on our diagram, 5.5 centimeters on your ruler, and the bearing is 65 degrees. So, well, I don't have a protractor, but this is going to be 90 degrees, isn't it, horizontally? Yeah. 45 is going to be approximately there. 65 is just going to be a little bit like this, isn't it? So what I would say pretty much is that the bearing is probably going to be something like this. If you get your protractor and just measure 65 degrees, it's probably going to be something like that. And then all you're going to do now is draw a line through there. And what you would do is just measure 5.5 centimeters on this line. And let's just say approximately it's about there, maybe. Let's just say this distance says 5.5 centimeters. So that would mean that you're going to label this as the town R right there. And obviously I can just rub out these lines here. So it's just easier to see. So yeah, that would pretty much be your answer. But obviously in the real exam, you'd have your protractor, which you'd be able to accurately measure 65 degrees, but it's probably going to be around there. And then obviously you'd work out how far 55 kilometers is in terms of centimeters, which is 5.5 centimeters. So you'd measure 5.5 centimeters here, and then wherever you get to would be a town R. So that would pretty much be it. So I hope that makes sense for question 16 and 17. Okay, so question 18 says we need to solve 4 times by 2x minus 3 is equal to 24, 3 marks. Let me just zoom in a bit so you can just see that question. But yeah, solve that for 3 marks. Now, what you'd want to do is you'd want to first expand the bracket. So if I expand the bracket, I'm going to have 8x minus 12, and this is going to equal 20, sorry. Now what I'm going to do is I'm going to add 12 to both sides. Remember, we're trying to get x on its own, so we need to isolate this. We need to get rid of this minus 12, and we also need to get rid of this 8. Now you always get rid of the number furthest away, which is a minus 12. So I'm going to add 12 onto both sides. So that will give me 8x is equal to 20 plus 12, and 20 plus 12 is 32. Now we've got this, we're trying to get x by itself. We can get rid of that 8 by dividing because the 8 is multiplying at the moment. So we're going to divide both sides by 8. That will give us an x here. 32 divided by 8 is just 4. So therefore x is just equal to 4. And that will give you 3 marks. Now, let's do question 19. Question 19 says, Jenny invests £3,000 for 6 years at Y%. simple interest per year. At the end of the 6 years, Jenny has received a total of £450 in interest. Work out the value of Y, and this is another 3 marker. So remember with simple interest, right? What happens is that you start with an initial amount, you get a percentage out of that, right? And that will be your interest. And that is the same year on, year out. So the initial percentage that you take off your original amount, that is going to be the amount you add on every year. So the fact that they've told us that it was for 6 years and Jenny received a total of £450, that will tell me that the 6 years, we could say, is just equal to the £450, right? Because the interest rate is the same year on year. So we can use this to work out how much she got for 1 year or the first year or a year, same thing, right? And all we're going to do here is we're just going to divide by 6, aren't we? So I'm going to just do that, divided by 6, like that. So it's going to be 1 year is equal to, now I need to do 450 divided by 6, might as well put on your calculator. 450 divided by 6 is going to equal 75. So what this tells me is that whatever percentage that Jenny got, or whatever the interest rate is, the simple interest rate is, it got her £75 from the 3,000, right? Because that's her initial amount. So what we need to do is ask ourselves, what percentage is £75 out of £3,000? And this is very, very simple. All you're going to do is you're going to do 75, the amount, divided by the total 3,000. You're going to write it as a fraction of it. And then you're just going to times by 100. And then we're just going to work out what this is. So 75 over 3,000 over 3,000 times by 100 gives me 5 over 2, which is 2.5. So it's 2.5%. So therefore, the answer for Y is just going to be 2.5. So Y is equal to 2.5. And that's it. And that will give you the 3 marks. Okay, so question 20 says we need to simplify m to the power of 2 all to the power of 3. Now remember with this one, it's just index laws. You should know that if I have a to the power of b, and this is all to the power of c, this is just equal to a to the power of b times by c. So all you're going to do in this case is just multiply the powers together. 2 times 3, this is equal to 6. So therefore the answer is just m to the power of 6. Next one again, we have to add the powers now. If it's a to the power of b times by a to the power of c, then this is equal to a to the power of b plus c. So all you're going to do is just add those together. So 5 plus 8 is equal to 13, isn't it? So therefore it's just x to the power of 13. And now part C says we need to expand that. So 4p times p squared plus 3p. So again, you start with the thing on the outside and you're going to multiply everything inside. So if I do 4p times by p squared, I have a 4 there. Then I've got p times by p squared. Remember, p is the same as p to the power of 1. So it's going to be p to the power of 3, isn't it? And then plus, and then we've got 4 times 3, that's a 12. And then we've got p times p, that's p squared. So therefore the answer is just 4p cubed plus 12p squared. And that's it. Question 20 finished. Okay, so question 21 says Johnny wants to know how much coffee he will need for 800 people at a meeting. Each person who drinks coffee will drink 2 cups of coffee. 10.6 grams of coffee is needed for each cup of coffee. Johnny assumes 68% of the people who will drink 68% of people will drink coffee. Part A says, using this assumption, work out the amount of coffee Johnny needs. Give your answer correct to the nearest gram. This is 4 marks. Right, so firstly, there are 800 people, and Johnny's assumption is that 68% of people will drink coffee. So let's work out how many people Johnny assumes will drink coffee. And all we're going to do to work that out is to do 68% of 800. And remember, this is a calculator paper, so all you need to do is convert this into a decimal, divide by 100, which is 0.68. We know that of means times, and then 800. So all you're going to do is put this into a calculator, see what we get. 0.68 times by 800 is equal to 544. So there are 544 people that are going to drink coffee according to Johnny, right? Okay. Now, what do we know about coffee? They've told us that each person who drinks coffee will drink 2 cups of coffee. So I'm going to say one person equals 2 cups of coffee. I'll just write 2 cups. Okay. And we know that there are 544 people. So all we're going to do is multiply that by 544. So 544 people must equal 2 times 544. You can put that in your calculator, but it's just 1,088. So that means we need 1,088 cups of coffee. Now, we also know how many grams there are per cup of coffee, 10.6. So what I'm going to say is that 1.6, sorry, not 1.6, 10.6 grams is going to equal one cup of coffee. And I know, oops, sorry, cut properly. Whoops. Okay, so one cup. And I know that there are 1,088 cups that are needed. So all I'm going to do is times by 1,088, aren't I? To figure out how many cups I need. So times by 1,088. And I'm going to do that here as well. So 1,088 times. So I'm going to do 1,088 times by 10.6 and see what that gives me. So 1,088, whoops, 1088 times by 10.6. This gives me what's that? 11,532.8. 11,532.8 grams of coffee. So that is how much coffee we need in terms of the grams. And we need this correct to the nearest gram. So to the nearest whole number. To the nearest whole number, that's just going to be 11,533. So the answer is just 11,533 grams. And that's it. That'll give you 4 marks. Now, part B says Johnny's assumption is wrong. 72% of the people who will drink coffee, 72% of the people will drink coffee. How does this affect your answer to part A? So, what did we work out in part A? We worked out how many grams are needed for Johnny's assumption, right? In terms of 68% of people, which was 544. If this percentage is increasing, that means there's going to be more people, which means that we're going to need more cups of coffee. So, how would it affect the answer? All you can say here is that we will need, or to be fair, just to be very specific, right? The answer to part A is the amount of grams. So all you're going to say is the amount of grams of coffee needed. Oops, coffee needed will increase as there are more people. And that's it. And that's question 21 finished. Okay, so question 22 says ACF and ADG are straight lines, BCD and EFG are parallel lines, and we need to show that the triangle ACD is isosceles. Give a reason for each state of your working. And this is how many marks? This is 5 marks. Okay, so firstly, for us to be able to answer this question, we need to remember what an isosceles triangle is. And it's just a triangle whereby you've got two angles which are the same. Let me just draw a better triangle. Yeah. So you've got two angles that are the same. I'm going to call these X like that. And then the sides are also the same as well. So this is a definition of an isosceles triangle. So in other words, we're looking for a triangle whereby two of the angles are the same. So what have they given us in terms of information? They've given us two angles here. Now we're dealing with parallel lines as well. So what you also need to be aware of is your angles in parallel lines. There are several different rules. There are vertically opposite, corresponding, co-interior, and alternate, right? So you need to know these off by heart. So what you want to do is basically build your way up until this triangle ACD, figure out what the angles are, and you should hope to get two of the angles being the same value. So firstly, what I can see here is, well, straight away, I've got a straight line here, and that means that I can work out what this angle is here, isn't it? We know that angles in a straight line add up to 180. So if this is 110, then this angle is going to be 180 take away 110, which is 70 degrees. So what I'm going to do, remember, it says you need to label, give a reason for each stage of your working. So I'm going to say first reason or first statement I'm going to say is angle ADC. We'll say angle ADC is equal to 70 degrees as angles on a straight line add to 180. Angles on a straight line. All right, I'll just do this for a straight line. Add to 180. So that is the first one. Okay. Now, what else can I see? I can see this angle over here, like this. And what I'm going to do is I'm going to highlight this right here. As you can see, I've got basically a backwards C. And if you remember your angles in parallel lines, then this is just co-interior angles, isn't it? Whereby this angle here and that angle there, these two angles, they must add to make 180. So to work out what this angle is here, you're going to do 180 take away 125, which is just 55 degrees, isn't it? So what I'm going to say here is that that angle, which is angle BCF is going to equal 180 take away 125 degrees, which is equal to 55 degrees. And then your reason is going to be as what can I say? Angle, this angle here, angle EFC, the 125 degrees, and the angle that we've just found, angle BCF, are co-interior angles. Co-interior angles. Perfect. So we've got that. And obviously, let me actually label this to be 55. So that's 55 degrees. Okay. Now, as well as that, what I also noticed, remember, you're trying to build up to work out what this what the angles are in this triangle here. If I do this and I do that, then I've actually got an X, don't I? I've got an X. Remember, when you have like an X shape, like this, like that, and you've got an angle here and an angle here, these are what we call vertically opposite angles. And these angles are the same. Yeah. So what that tells me is that this angle over here has to be 55 degrees as well. And that angle is ACD. So what I can now say, let me just zoom out a bit. I can now say that angle ACD is equal to 55 degrees, right? As it is vertically opposite with, it is vertically, hold on, vertically opposite to angle BCF. Okay. Brilliant. Now remember what we're trying to do. We're trying to show that a triangle ACD is isosceles. We've got two angles out of three. We don't need any other angle and parallel lines rules. We can just work out the third angle by adding these two together and then taking it from 180. So let's do that. 55 plus 70 is going to equal 125, isn't it? That's going to be the sum of these two angles here. To figure out what this angle is at the top, I'll highlight it in green. We're going to just do 180 take away 125. 180 take away 125 is equal to 55. That's something we did already, isn't it? I believe. Yeah, we did it here. Right? So that means that this angle here is 55 degrees. So what do we have? We've got triangle ACD. Two of the angles are the same. So it must be isosceles. So what you want to do just to finish it off, right, is we need that last rule. So angle CAD is equal to 55 degrees as, let me just make sure that's the correct angle. CAD, yep, yep. As angles in a triangle sum to 180, right? And now that you've got that, you can say that two angles in this triangle are both 55, so therefore it must be isosceles. So all you're going to say here is that angle CAD and angle, uh, what is that? CAD, that one, and ACD is equal to 55, yeah? So we can say that the triangle, so I can say triangle ACD is isosceles. And let me just make sure I'm spelling that correctly. Yeah. And that's it. And that will give you the full 5 marks. So just make sure you have all of your reasonings and you have it step by step, and you should be fine. Okay, so it says for question 23, it takes 14 hours for 5 identical pumps to fill a water tank. How many hours would it take 4 of these pumps to fill another water tank of the same size? Now, with this type of question, it's inverse proportion. Just have a look at it, think contextually, right? Or in the context of this question, right? 14 hours for 5 pumps. So I'm going to write 5 pumps is equal to 14 hours. Now, if we're dealing with fewer pumps, it should take longer for it to fill water, isn't it? Right? So what you want to do is say, okay, well, fine. Well, if 5 pumps take 14 hours, then one pump, you're not going to divide by four, you're not going to divide by five, right? You're going to times by five, isn't it? Because remember, the 5 pumps is split in the amount of time. Yeah, 5 ways. So you're going to times this by five to figure out how long it will take one pump to fill a water tank. So I'm going to just do 14 times by 5. That is 70, isn't it? Yeah, that's 70 hours. So now we know how long it takes one pump, and it's asking us for 4 pumps. So what we're going to do now to get 4 pumps is now we're going to divide this by 4 because we're going to split it 4 ways, aren't we? So we're going to divide by 4 now. 70 divided by 4 is equal to 17.5. So the answer is 17.5 hours. So that's question 23. Let's go to question 24. Question 24 says A and B are numbers such that A is equal to 2 squared times 3 to the 4 times 7, and B is equal to 3 squared times 7 squared. Find the highest common factor find the highest common factor HCF of A and B. So what I would like to do with this type of question, right, is I would always draw a Venn diagram just to make it super clear. Right? So I've got two numbers A and B, and what we're gonna do is just put this into our Venn diagram. Now, obviously the middle is going to have the factors that they both have in common. So what you can do just to make it really easy is going to write this out. So 2 squared is 2 times 2. 3 to the 4 is 3 times by 3 times by 3 times by 3. And then we'll times it by 7. And then the bottom one is 3 squared, which is 3 times 3 times 7 squared, which is 7 times 7. So now, what do they have in common? Well, if I look, there are no 2's in common, so I'm not going to look at that. I can see a 3 here, I can see a 3 here, I can see another 3 here, I can see another 3 here, and there's only two threes that they have in common. So I'm going to put a 3 squared here to represent these two, and I'll just put it in yellow so it's super clear. Yeah? Okay. Now, looking at the sevens, there's one 7 here, and there's one 7 here. So I'm going to put a 7 here, like that. So that will go inside. And then now let's just fill in the remaining part. So this here and that there will go on the outer part of A. So there's two twos there, so I'm going to put 2 squared there. And then there's two threes there, so I'm going to put 3 squared there. And then now there's only just one 7 here, isn't there? Like that. Perfect. So now, question asks us for the highest common factor. When you filled in your Venn diagram, the highest common factor is just the overlap, the intersection. So it's just going to be 3 squared times by 7. 3 squared is 9. 9 times 7 is 63. So the answer for the highest common factor is 63. Remember, you can use your calculator as well. Part B says find the lowest common multiple of A and B. Now remember, to find the LCM when you're dealing with these types of questions here, and you've got a Venn diagram, it's just the product of everything inside the Venn diagram. So the middle and the outer parts. So all you're going to do for the answer for the LCM is you're just literally going to times them all together. It's going to be 2 squared times by 3 squared times by another 3 squared times by 7 times by 7. So everything times together. You're going to put this in your calculator, see what you get. So I put it in here. It's going to be 2 squared times by 3 squared times by another 3 squared times by 7 and another 7. This gives me 15,876. So that is our final answer for part B. And that will give you how many marks? 3 marks for question 24. Let's go to question 25 now. So it says lava flows from a volcano at a constant rate of 11.9 meters cubed per second. How many days does it take for 67,205,600 meters cubed of lava to flow from the volcano? Give your answer correct to the nearest day. Okay, so with this one, they've told us the rate at which it's flowing out, right? So 11.9 meters cubed per second. That just tells me that for every second, we have lava flowing out at 11.9 meters cubed. So I'm going to say 11.9 meters cubed is going to equal 1 second. And we need to work out how many days it takes this. Now, we're dealing with seconds at the moment. What you'd want to do to make it easier for yourself is convert this rate into days, right? To see how much it will be per day, and then just figure out how many of the volume that you get for the lava will go into this number. So it's not too bad. So first I'm dealing with seconds. I want to change this to at least a minute, right? Which is obviously 60 seconds. So I'm going to times this by 60, and I'm going to put 11.9 times by 60. That gives me 714. So I'm gonna write 60 seconds here, right? But I'm gonna put a minute here. 1 minute. They're the same thing. I'll put this in a bracket, right? And this is 714 meters cubed. Now, we've got 1 minute. Let's figure out an hour by times them by 60 again. So I'm gonna do 60 minutes now, just so it's clear. But remember, that's the same as 1 hour. So I'm gonna times this by 60. 714 times by 60 is equal to 714 times 60 is equal to 42,840. So 42,840 meters cubed of lava is flowing out every hour. Now we can now figure out how much lava is thrown out per day by just doing 1 hour times by 24, because there are 24 hours in a day. So I'm gonna write 24 hours here. which I know is the same as 1 day. So I'm going to work out 42,840 times by 24. 42,840 times by 24. This gives me that number there, which is 1,028,160. 1,028,160 meters cubed of lava is thrown out every day. Now we need to figure out how many days it takes for that amount, which is 67,205,600 meters. So I'm just going to write this here. I'm going to write question mark days like that. And then I know how much we need to get to, which is that there. So all you want to do is just say, well, how many of this number here goes into that number? And all you're going to do is just divide, isn't it? So I'm going to do get a fraction 67205 600, and I'm going to divide this by 1028, and then it's going to be 160, isn't it? There, and that gives me 65.3 days, essentially 65.3 days. The question asks us to give it correct to the nearest day. That's just going to be to the nearest whole number, which is just 65 days. And that's it. And that's question 25 finished. Okay, so question 26 says, here is the graph of y equals x squared minus 2x minus 2. Part A, we need to write down the coordinates of the turning point on the graph of y equals x squared minus 2x minus 2 for 1 mark. So this one is very, very easy. The turning point is just literally where the graph turns, right? Which is going to be at the bottom right hand. And we can see that the x coordinate is 1 and the y coordinate is minus 3. So therefore the answer is just going to be 1 minus 3. And that will be it. Part B says we need to write down an estimate for one of the roots of x squared minus 2x minus 2 is equal to 0. Now that is a keyword root. Whenever you see root, when it asks you for estimates of a root, it's just ask you to find what values of x makes the graph intersect the x-axis. So you're just going to look at the points of intersection, right? So as you can see, there are 2 points of intersection there and there. They've only asked for one of them, so I'm going to just choose this one on the right hand. Now, if I look closely, there's 5 boxes between 2 and 3, so it must be going up in 0.2s. So 2.2, 2.4, 2.6, and then 2.8. And this looks to be bang in the middle of 2.6 and 2.8, isn't it? So I'm going to say approximately, as an estimate, that's going to be 2.7. So therefore, I'm just going to say 2.7. And that will be it. That will give you the marks for question 26. Let's go to question 27 now. Question 27 says, a solid cube is made of metal. The metal has a density of 9 grams per centimeter cubed. The volume of the cuboid is 72 centimeters cubed. Work out the mass of the cuboid. Now, this is compound measures. You need to know your formula. Remember the formula for density, right? Density is equal to mass divided by the volume. However, they are not asking us for the density. They're asking us for the mass. So we need to rearrange this. How do I rearrange this? Well, I need to get rid of this V here. So I'm going to just times both sides by V. So it becomes D times V is equal to M. So therefore, if I want to calculate the mass, it's just going to be equal to the density times the volume. Or you can use a formula triangle, can't you? Like that. So D, M, V, and then just cover whatever one you need. If I cover M, it will be D and V. So it's D times V. Now the density is 9. The volume is 72. So all you're going to do is just do 9 times 72 into your calculator. 9 times 72, this is equal to 648. So the answer is just 648 grams. And that's it. And that is question 27. Now let's go to question 28, which is the last question, I believe. It says we need to write 9 times 10 to the 4 to 4.5 times 10 to the 6 in the form 1 to n, where n is an integer. Okay, so remember, this is a ratio. So although it's in standard form, it's still a ratio. What you could do, just to make things a bit clearer, is you could just convert these into whole numbers, just so it's just a bit easier to look at. That's 90,000. So that's going to be 90,000 here. You don't have to do this though, but I'll just do it anyway. And then I'm going to do 4.5 times by 10 to the power of 6. And that gives me that number there, which is 4,500,000. 4,500,000. Okay. Now I need this in the form 1 to n. So what that means is that I need to just get this to be a 1. And what that means is that I'm going to just divide both sides. Remember, ratios have to be equivalent. I need to divide both sides by 90,000. So I'm going to do that and see what I get. So I'm going to do that number there. I'm going to do that there. I'm going to put answer because it's a long number. I don't need to write out again. I'm We'll do that divided by 90,000, and that gives me 50. So therefore, that just means that n is equal to 50. Perfect. 1 to 50. Brilliant. Now, part B says we need to write the following numbers in order of size. Start with the smallest number. Again, some are given in standard form, some are not. So what you could actually, to be fair, these aren't in standard form actually, but they look similar to it because remember, this has to be between 1 and 10, the number anyway. So what you could do is, yeah, you've got a calculator. You pretty much can just calculate all of these and see what they are as actual numbers. So I'm going to do the first one. 5.625 times 10 to the power of 4 will give me, whoops, will give me 56250. So I'm going to write 56250 here. 5625 is already done. And I'm going to do this one. It's going to be 5625250. And it's going to be times by 10 to the minus 3. And it gives me 56.25. And then the last one is going to be that number there, 0.005625, and we'll times that by 10 to the 5. And that gives me 562.5. Now it asks us to give us write the numbers in order of size, start with the smallest. So we can see quite clearly the smallest number is this one. So I'm gonna write like this: 56250 times 10 to the minus 3. That's going to be the first one. The next larger number is going to be this one, isn't it? 0.005625 times 10 to the 5. Next one's going to be 5625. And then the largest number is 5.625 times 10 to the power of 4. And that's it. And that will give you 2 marks and 4 marks in total for question 28. And I believe that is the end of the paper. Yes, it is. That's paper 3 finished. Hi guys, Daniel here. Hope you guys are doing well. So yeah, we made it to the end of the paper, and yeah, as you can see, there was a couple of tricky questions in here, but again, I do feel it was the easier paper out of the 3. So hopefully you didn't find it too bad. And if there were any questions that you did find difficult or tricky, I'm hoping that this video has helped you understand it and you're in a better position for your GCSEs. And yeah, again, thank you for all the support. If you know anyone that would be interested in these videos, then feel free to just let them know, like, comment, subscribe, and that will be much appreciated. But yeah, stay tuned. I'll definitely be doing a lot more videos and walkthroughs as well. So yeah, that's it from me. Good luck with your exams, and I'll see you guys soon. Take care.